Okay, I strongly recommend you watch the video for hypothesis tests for the mean using critical value method with z-test first, because in that video I go in more in the detail. Here I'm just going to show how it differs for the t-test. So first of all, how do we know that we have to conduct a t-test instead of a z-test here? Well, it's going to boil down to whether or not we have sigma, whether or not we have a population standard deviation. And here, notice that we do have a standard deviation, the 845 calories, but notice that that's coming from the sample. It even tells us it's the sample standard deviation. They might also say a sample of 24 cyclists with mean of blah, 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 and standard deviation of blah, blah. But the question is, the standard deviation that we have, is it coming from the sample or the population? If it's from the sample, we have to use t-test. If it's population, then we can use z-test. And z-test is always kind of our plan A, if you will. But other than that, things are going to flow pretty similar, especially for the critical value method. So our null hypothesis, it's always the nothing, should always have an equal sign in it. We're doing a mean, so this should have the mu, the population mean. And what's the nothing situation here? Well, we want to see if the calories burned is less than 6,200. So the null, the nothing hypothesis would be, well, it's not less, it's just boring old 6,200 here, nothing going on. The alternative, because of that directional word less than, we are going to use the less. Remember that these two always match and the numbers always match. Only the symbol is different between the two hypotheses. Okay, performing a hypothesis test, so number of degrees of freedom. How do we get this? Well, if we're just dealing with a single sample, it's just one less than the sample size. So we have 24 here. We're going to subtract 1 to get 23 degrees of freedom. And that'll give us a particular distribution. Once we have the mean, which we have here, we have our standard deviation, which I guess we haven't really put in, but they calculated for us. And then the degrees of freedom will give us a unique t-distribution. One or two-tailed? Well, we already decided it was one-tailed here when we put the less than sign. Two-tailed would be based on this sign right here. And that was based on the question where we were looking, is it less than 6,200? So because of that, we put less than, and we have a one-tailed test. Critical value. So here we're going to have to use our level of significance, and they do tell us that the T button on the right there on the calculator will give us 0.10 in the right tail. Is that what we want? Well, we actually are going to be able to reject our null hypothesis only if it's far enough below less than. So we actually want the right tail. So we want to be we want to the left tail, not the right tail. So we want to be shading something down here. So the question is, how do we get that? If we put in, let me just show you. If we put in T 0.10 with 23 degrees of freedom in the calculator, it's going to give us this over here. Let me go ahead and enter this, 1.319. But we want the left side because we're conducting a left-tailed test. So how do we do that? Well, two ways. We could put in the negative version of this. It is symmetrical. So let me do that first. Or we could also, instead of putting 10% to the right, we could put 90% to the right of what our value is. So this number right here, if it was 90% with 23 degrees of freedom, it would directly give us this critical value. So you can either get the version on the right and take the negative of that because they're symmetrical, or you can realize that to get 10% on the left, 10% in the tail, and that's coming from this right here, to get 10% in the tail, I need 90% to the right. So if I'm going to use my button here, I can put 90% in. Test statistic is going to come as a calculation from this formula here. So let's do that. So our sample mean here is 6125 minus our null hypothesis mean, which is 6200, divided by, very similar to the z-test here, we're using sample standard deviation though, so 845 since we don't know sigma, divided by square root of n, and there's 24 cyclists. So we'll take the square root of that. And this will give us our test statistic, negative 0.435. Okay, so this was our rejection region. We had to get into this region in order to reject. This is beyond the critical value. And this is where we were, where you see the line. We were not in the rejection region. We did not have evidence to reject that null hypothesis and support the claim. So since the value doesn't lie in the rejection region, the null hypothesis is not rejected. Read these closely. It's not rejected. So there's not enough evidence to support the claim that blah, blah, blah is less than 6,200. Again, our sample was below that. Our sample was 6125, but it wasn't far enough below for us to believe that that would happen in general, even beyond this sample.